Keast. This is my final project on time series forecasting. So this was a Kaggle hosted competition based on data provided from the Ecuadorian chain of supermarkets Favorita. The purpose of this research was to build a model to forecast sales for hundreds of different product categories sold at stores, dates, shop, and product information, whether the item was on promotion, and sales quantities were all used to train a predictive model. What is time series forecasting? Time series forecasting is the process of evaluating timestamp data using statistics and modeling to provide forecasts and inform future strategy. So time series is used in a lot of industries, from predicting the price of commodities to stocks, as well as AWS uses it to predict their web traffic accurately. So to begin this project, I wanted to get an understanding of the data set. As you can see, it's a list of daily timestamp sales organized by product family and store location. And on the right, I grouped them by week, average sales over a week and month to get a general overview of how things looked. So on the simplest scale, we can create a linear prediction of future sales, but we can do a lot better than this. One way of doing this, we should begin by adding features. It's called feature engineering. These are more trainable parameters for our model. Ecuador, very oil-dependent nation, so price of oil can greatly affect weekly sales. I added in a 7-day moving average and the standard deviation of weekly oil prices. Seasonality is also another important concept in time series forecasting. You can see that over the course of a week, people tend to do more of their shopping on weekends than weekdays. Similarly, if we look at the whole year, at the end of the calendar year, during Feliz Navidad or Ecuador's Christmas season, there's a huge spike in consumer activity. So if we build these frequencies into our model, we get additional trainable parameters. So I did so here, and you can see that the holiday prices are greatly, or the spikes in holiday spending increase or are accounted for in the model. And we're able to predict future months after that. So this is already a great improvement from the linear model we were working with earlier. So different learning methods. So after all these additional features have been engineered, it was time to begin training a model using the different learning methods. The three I used were linear regression, random forest regression, and extra trees regression. The latter two methods, they're very similar in that they both composed of many decision trees, which output the mean of all classes as a prediction of the trees. Visualization of this can be seen here on the right. Now for the results. So I submitted the best performing model, which was the random forest regression, and gives back a root mean squared log error is how the competition judges the performance. And I got an RMSLE of 0.51, which was good enough to place in the top 250 of nearly 1,000 submissions. If I were to continue this project, I would have probably explored a lot of different models, maybe a neural network-based model, as well as tuning for different hyperparameters for training, which I didn't get a chance to do much of with this one. But that's my presentation, and thank you for listening.